Hi guys, Matt Hendricks here with another video. This one's going to be again about AI hardware. There was a lot of questions about my previous video about my install for the install of the A100 water cooled, and people were wondering about different parts that I had in that server. So I thought I'll answer a lot of those questions with this one and take a deep dive into the process I went through with deciding whether to make the build, what parts that I decided to put in the build and why, how much it costs, that kind of stuff. So let's get into it. So first of all, I didn't have any experience really building computers or servers before this, but I picked up the skill really fast after I saw how much it was going to cost to buy an AI server with the specs that I wanted. So the first thing I want to talk about is why I decided to build these. And then I'll go through the parts list and talk about why I decided to buy the parts that I did. And I'd be really interested in feedback on if you guys think there's other parts that would have been better or cheaper or something like that. And then I'll walk you upstairs and I'll show you all three of the builds. They're almost identical. The only I really have been lucky, like almost all the parts that I picked, I've been really happy with. I've only changed a couple of things from the first build to the last build. And really they weren't totally necessary changes, and I'll talk about that. I just changed the power supply and the main power supply and the fans for the third build, which turned out really probably wasn't necessary, but really small tweaks. So let's get into it. First of all, why did I decide to build my own servers, even though I've never built any computers up until this point? And so the short answer is really expensive to buy the servers that I wanted to buy. And I wanted to try to minimize the cost as much as possible. And it turned out, wow, I looked at the parts. If I actually built a similar rig, I would save about 50%. So that's really the focus of this video is how did I save 50% on building my own AI servers? So here's a first step that I went through is pricing out what it would be to buy something that I wanted. So here's what I wanted. I want at least four GPUs, preferably A100s. I decided on the A100 just because it's more value for your buck. An A100 GPU is about 15 to 17,000 new. An H100, and I wanted at least 80 gigs, right? I want to do serious AI work, and you can't really do that if you don't have at least the 80 gig cards. So an A100 is the cheapest 80 gig card that I know of. The next step up is the newer generation, the H100s, but those cost double. And I did some testing. The rumor was that they were twice as fast, so it seemed to justify the price. But for what I was doing, they were not twice as fast. So the most efficient route for me to go with the GPUs would be the A100 80 gig. All right, so I wanted at least four of those, and preferably even more in one system. The more you can pack into one system, the more efficient, right? If you can have like one CPU, one motherboard match up with 8 or 7 A100s, that's going to be more efficient than having, like price-wise, than having to, have max 4 per card or per CPU per motherboard. So I wanted it to be at least 4 and preferably able to upgrade higher than that and make the server even more dense. So here's what I started with. I basically price out like what's the most inexpensive build that would get me 4 A100s. Here's one option from Bison. It turns out that for a lot of cases, if you want to go more than 4 cards, even getting 4 cards into a server is a little bit complicated if they're not water cooled, because when they're air cooled, they're 2 slots. All right, so that's going to take up a lot of space, and there aren't a ton of motherboards that will accommodate more than 4 cards with 2 slot spacing. All right, unless you do like risers or something like that. I didn't want to really mess with that. I just want to plug these cards right into the motherboard and preferably get above 4 eventually. And so the best route for that is to have water cooled. If you do a water cooled A100, it takes 1 slot rather than 2. So you can pack in theory, twice as many cards into the same motherboard and not have to use risers or anything like that. So that was really attractive to me, and Bison has this system that looked very close to what I wanted. Actually, what I ended up building is very similar looking to this, and you'll see in a little bit. All right, so as far as CPU goes, I don't need a really powerful CPU. The big thing about the CPU is you just need to make sure that it will run has the PCIe lanes, so that it will run the GPUs at full speed in terms of the transfer of data. And there aren't many options to fit. I mean, basically you need 16 lanes per card. And so that means you're going to need like a Threadripper or a Xeon, or there's another, EPYC is another kind of chip. But once you get into those chips, you have plenty of lanes. You don't need to have tons of cores. Like, I'm not doing CPU intensive tasks with AI. So having the least amount of cores, but having all of those PCI lanes is perfect. So this is actually the processor that I went with the build. And this is the one I'm selecting for this option here. No overclocking. Cool. It's going to be water cooled. Another thing is I wanted it to have 512 gigabytes of RAM. It seemed like the sweet spot. If you go above that, it gets really expensive because you're talking about, so you have 8 slots typically in the motherboard. And to get to 512 gigabytes, you need a 64 gig RAM stick, all right? Once you go above 64 gig, it seems to get quite expensive. So it was sort of the sweet spot for me to get a lot of RAM, and so that's not going to bottleneck there and not have the price explode. So this is what I ended up going with, was 8 sticks, 64 gigs, so 512 gigs total of RAM, and that works just fine. All right, so we're going to do 4 GPUs. So I selected this on their website. This is Ubuntu. That should be free. That's a free operating system. Okay, so here's where the price really skyrockets, right? I want 4 A100s liquid cooled, and I select that option here, and then everything else, 4 terabyte M2 drive. That's what I've got in the servers that I've built, and that's it. Everything else is pretty standard here. Notice I don't have a monitor, any peripherals, no UPS selected here, because this is going to be important. I'm going to show you the price list with all of that included. But notice the price here for this system is $143,000. And so that's the first bit of information I had about, like, what's this going to cost to get a server that has the capabilities that I want. So 143 is this price. There are a couple other options I want to show you. One is an NVIDIA DGX station. This has 4 A100s in it. I'm not sure whether I can get this. They're air cooled, but they are linked to have like really high transfer across the cards. Turns out to be not super important really for what I'm doing as well. If you're training a model from like scratch, that would probably be pretty important with lots of different nodes. But for what I'm doing, I'm mostly fine tuning. I am going to train a small model from scratch, but it's not like, a GPT-4 level, or even GPT-3 kind of number of parameters. I'm not using trillions of parameters or even hundreds of billions. So this system here is 130K, but I highly doubt you can even get it. So you can see that's verify that's in stock, and it won't be. So 130K for that. That's air cooled though. It's no ability to really upgrade this. And it's all going to be kind of like custom DGX NVIDIA stuff. It's going to be probably really expensive to just maintain if anything breaks. Another option is from Lambda Labs. They used to have, I think, when I first looked, they used to have 4 A100 builds, but they don't even have them now. This is the most comparable system, but it's like half the performance of what I ended up building. The reason is they're using a 800 cards, which sounds like it would be better, but they're actually half the RAM. They only have 40 gigs of RAM per card, which is not enough for what, I mean, I suppose it would be enough if you're going to do a lot of, looks like they're NV linked here. I don't even know if that's, that might be part of the deal, but you can see these NV links here, 1 and 2. So that probably helps to kind of convert these. So it's almost equivalent in terms of RAM of having 2 A100 80 gig cards, but it will have also more processing capabilities. So This is somewhat, I mean, not as nice as what I was hoping for. Notice it's not upgradable. There's no more room to add any more slots or more cards or anything like that. This thing's pretty much maxed out. And this thing's $85K. All right. So those are the price ranges really to get what I wanted. Really what I wanted was like the Bison build here, and that's like 143K. This one's pretty awesome too, but it's not upgradable, air cooled, and it's got things that I probably don't need, like that Fast Connect, which is in the DGX systems. And this one is, you know, probably minimum of what I was looking for, and it's 85K, not really upgradable, expandable or anything like that. No water cooling, nothing. Okay, so those are the ballpark. Really what I wanted is in this 143K range, I thought. Then I started learning about, okay, what it would cost to build this thing. And just long story short, here's the price list. To build the system that will actually house the cards is about $7,000 for the parts. All right, and I'll walk you through the parts list. That's 512 gigabytes of RAM. That's the Threadripper, same chip on the Bison that I just showed you with 128 PCIe lanes. And it will accommodate up to 7 A100s water cooled right into the motherboard. So they're really attractive to me to have this ability to expand and try to keep the price down. So to build the actual system that will house the cards is about $7,000. You can see that here with this parts list. Virtually everything is on this parts list, including also the desk. I mean, some things that you wouldn't need. I've got, like you saw in the previous video, I've got this stand-up desk. I've got a monitor. You don't need that. Keyboard, mouse. You don't need that. But I have it all in here because this is my I actually ordered 3 of these. All right. Only thing that's not included in here I'll talk about is like a small cord that you need to buy from Struck from Corsair. But everything else is in here, and it comes out to about $7,000 plus tax, I believe. But you know, this is all from Amazon, so you can get cash back and stuff like that. So pretty inexpensive. I mean, relatively. And then on top of this, we got to buy the cards, right? So you want to know that A100 card I showed you in the previous video costs $15,000. It's a brand new A100 water cooled. I got 4 of them, so you're looking at $67,000 to build a system that's virtually the same as, in fact, probably better in many ways than this system here for 143. Hence the video name, right? It's less than half of the price of what this would cost. So at this point in my journey, I was like, okay, I got to learn how to build a computer to save 60 grand on just one workstation or one AI server, and I'm going to build several. It definitely paid for me to learn how to build these systems from scratch. All right, so that's the calculus. I'm an economist by training, by the way, so this is really sort of standard cost-benefit analysis to me. It's like, all right, what's the cost of learning how to build a machine? What's the benefit? Well, the benefit is going to be to save about 60 grand, 70 grand per system to learn how to build this thing. So really, really easy decision in my view. I also have the UPSs in here, which are $400. So I mean, you can see how I'm saving so much money building this thing myself. Those UPSs were not included on the Bison build. All right, so let's start with the part list. Probably the heart of the build was to pick the right case that would fit everything in there. And I went with this awesome Lian Li case. I'm really happy with it. Has tons of space. It's a really big case. And the cool thing about this case is it fits a lot of water cooling. So I have a 480 millimeter radiator in the front, 480 millimeter in the side, and I tried to fit a bigger one in the top, but I kind of ran into issues with the thickness hitting the motherboard was one issue. And then if I made it really long, then it kind of cramped the water cooling reservoir area. I probably could have fit a longer one, not a thicker one, but I ended up settling with a 360 sort of thin radiator on the top. All right. The cool thing about this case too is it holds 2 power supplies right in the case. One power supply, the normal form factor power supply on the bottom, and then you stack on top of that an SFX power supply. All right, and so those power supplies are here. This is the SFX power supply, the small one. It sits on top of the if you see in the previous video, it sits on top of the normal size power supply. And the normal size power supply that I have, let me try to find it here in this list. I'll share this list, by the way, I'll give a link. I think I can make a link to this. I'll share it in the video description. So this is the main power supply. And why did I choose this one? Let me show you why. One is it is got a lot of power, right? Almost 1700 watts, which is great. Each of those A100s takes 300 watts. The Threadripper and everything else takes another like 400 or 500 watts depending on the load. So this is great. This can easily power probably really on the edge, but right now I have it powering 600 watts worth of cards and another 500 watts worth of other stuff like the fans, the CPU, RAM, all that stuff. So plenty of headroom there. And another cool thing, which I'm zooming in on here, is that this comes standard with two 12 volt high power cords, and the hookups right there to hook into those graphics cards. The A100s, all the new cards are taking these big high powered cords, and it's nice to have that right out of the box. So these plugged into the two GPUs, and then everything else is standard. So I don't have to buy like extra cords or anything with this, which I really like that about this power supply. And yeah, it's been really reliable so far. So that's why I chose that one. This is actually one of the modifications I made. The first two builds, I went with EVGA, a little bit cheaper power supply, but I had some issues with it, and I had to RMA one. And the other is having the same issue. The voltage reading on, I think it's going to the RAM 3 volt. I can't remember if it's 5 volts or whatever, but maybe it's a 3 volt header. It's always low, and I keep getting on my BMC for the motherboard saying, hey, we're getting this low voltage reading from this power supply. It's not good. And so I was a little worried about that, about stability. So I switched to a different power supply. All right, so that's the case, power supply. The motherboard and the CPU, I already mentioned the CPU is the Threadripper, the lowest, 16 core, 32 thread. It's totally perfect for what we need. If I did go to like 7 cards, I might consider a higher core count, thread count, because, let me see, so 32 threads, that gives you 8 threads per card. Right. I guess it's good. I think the sort of standard rule of thumb is that you want 4 threads per card. So it's easily accommodate up to 7 cards even. So this should be good, future proof. The motherboard that makes this all happen, that's compatible with this high PCIe lane CPU, and has all these PCIe slots to fit the cards in, is this bad boy. And this is a really great motherboard. You can see it's got 1, 2, 3, 4, 5, 6, 7 PCIe slots. They're all at 16x generation 4. So that's the generation that the A100 is, and the max speed 16x. Another cool thing about this board is it has tons of power. I think it's these headers down here. Yeah. These are extra power to go to the PCIe lanes. And there's also extra power up here as well to the PCIe. I think it's this header right here. Those are excellent, right? It creates plenty of power going through these slots. All right. Another cool thing about this board is it has a built-in a VGA header. I mean, you probably saw in the previous video that I have a monitor hooked up to the thing. It's not hooked into the cards. The cards don't have any video output, but this board does have a VGA header, and I believe it's this header right here. It takes like virtually no video RAM, right? And it's just run, I don't know how exactly it runs, like through there might be a little chip on the board or something like that. So you can get video without even having video card on the machine. All right, then you can see the 8 RAM slots, and I think that's all that's interesting about this. Oh, it has built-in BMC too, which works through the network. So it monitors everything. I can log in on my home network and double check all the health stats, make sure everything is running fine. And that's where I was getting the error messages before from that old power supply that I swapped out. So that's really nice to monitor everything. Okay, and temperatures and everything like that. Let's see, voltages. All right, so to run 2 power supplies, you need this little adapter, really cheap, $9 part. It just makes sure that when you turn the machine on, it turns both power supplies on at the same time, so they act as if they're one. Really simple. I think everything else here is fairly boring, right? We just got a 4 terabyte M2. In the future, one of the things I'm running into is that when people are using my machine, they'll take up a lot of space on the drive. So what I'm going to do in the future is upgrade this to like 2 or 3. That motherboard will take a bunch of these M2 cards, and you can set them up in Linux so that they'll all act as one big drive. So that's what I'll be doing in the future. You can see the fittings, the coolant that I use. I say it's water cooled, but really it's some kind of coolant. It's probably 99% water, but there's some kind of additive in there. Let's see, the tubing. I couldn't remember the diameters I was using on the previous video, but there you go. There are 3/8 inch inner diameter, 1/2 inch outer diameter, and then the compatible compression fittings that go with that. You need 4 of these or so to make everything work. Here's the pump and reservoir. I believe this is like $300. It's not included here, but yeah, you can find this on Amazon or order it straight from EKWB. I think the version that I have in the Lenny system that you just saw last time, I got direct from EK for a really good deal. But you can get it straight from Amazon. The CPU cooler, here's the 2 480 millimeter radiators. I needed 2 of these case fan hubs to, there's 19 fans. I was wrong on the previous video. So I have 19 fans going into this thing. And in order to power all those fans and have them all run and power up and power down based on the temperature of the CPU or the GPUs, I needed to have them all connect at a hub. And that's a 10 fan hub. So 2 of those is what you need. And you plug those hubs into the CPU header on the board, and it will power up, power down, rev up, rev down the fans based on the temperature of the CPU. But you can set it to rev up, rev down based on any temperature you want. If you want to get more complicated, and you could set it up to run off the temperature of like the coolant or the temperature of the GPUs themselves. There's lots of different options. I also have the pumps. The pumps are plugged into just a normal fan header, and they run at 100% speed. Actually, they're probably not plugged in at all. If you don't plug them in, they just run at 100% speed all the time. And I just wanted to do that for safety. I have 2 pumps in this thing, and I really, really don't want the pumps to stop, right? And I don't want them to be slow. So I just had run them 100%. I have this little pump. You can see, I'll show you, it sits kind of out in the front. And then the other pump is on the bottom of the the reservoir, this guy here, right? This is a pump at the bottom here. So 2 EK pumps, they're identical pumps, and then this reservoir that holds all of the coolant, the extra coolant. Here's the 512 gigabyte RAM kit. It's a little bit difficult to find this. It's ECC, and it's $1,300. I'm wondering if people that watch this video might say, oh, that's a bad price or something, and maybe there's a better deal for 512 gigs. I'm not sure. This is the CPU cooler. One thing I learned the hard way is that this actually is a lot of water cooling parts. Doesn't matter which way the coolant flows through it. That is not the case for this CPU cooler. On my first build, I installed it incorrectly so that the intake and the inlet and outlet on the cooler were not set up properly. I believe when you set this up, this is the in hole, so be careful. This is where the in is, and this is the out, and I had it the opposite direction, which is a big no-no because my CPU got really hot and I could not figure it out for the life of me. And then I finally figured out in small print on the Corsair cooler docs that this is direction specific, which made a huge difference when I switched these. Okay. These are just for aesthetics, right? This little remote control plugs into the RGB. So there's RGB on the pumps and the cooler, the CPU cooler. You can turn those lights on. You saw that in the previous video. And I'll show you that up here. I can just control this with the remote here. And there's also these, we're splicing off. There's 3 different things that are RGB that need to plug into this one thing. So this is just a splitter that does that. All right, I think that's it as for the parts. All right, so again, one more thing. So I went with this fan on the 3rd build. This is a much higher RPM heavy duty fan that costs twice as much as the fans I used on the first 2 builds. But I was curious if I could get better cooling capabilities out of using a more industrial type fan. So I went with this fan on the 3rd build. On the first 2 builds, I went with this fan. That's half the price, but also half the speed or so. All right, so I guess what I learned from this is if you care about like how loud the machine is, definitely go with this. These seem to be just fine. 19 of these keeps everything nice and cool. I haven't had any issues with the 2 builds I went with these fans. I say that because these industrial fans are very loud, like really loud. And the wife is not super impressed with these fans. So I would say if you want to save a little bit of money and you care about how loud it is, definitely go with these gray fans here. These are lower RPM and they're half the price, which adds up really fast when you're buying 19 of them. But if you don't care about sound, which I don't really that much, these are definitely much better fans. They will cool. They push the air through the case much harder, right? But you do need to it will make you go deaf if you don't adjust the speeds better in the motherboard. I had to do that. Whereas those other lower RPM fans, it wasn't a huge deal as to like what RPM they were running at. Okay, one thing that I learned here, this UPS, it will take up to 1,000 watts. And we've got 2 of them, right? They're split. And I did have an issue that one of my UPSs was rated at 900. That was a different brand. This one's rated at 1,000 watts. And there are several occasions where my servers, one of these will be pulling from a UPS at like 900 or 1,000 watts. Above 900 at least. And when I did have a power outage, the backup failed, right? It was over the rating of 900, which I was like confused right away why that happened. But it turns out, it was over 900 and the UPS just basically shut off and didn't do its job. So these are awesome in that they're pretty inexpensive and they will support up to 1,000 watts of pull and keep the machine running at least for a few minutes while that's happening. So there's a really small power glitch, like flicker on off, and totally the UPS did not do its job. And so I'm going with these all the time now. They're excellent. I've had great luck with them. All right, that's it for the parts list. Oh, there's one more thing I was going to show you. So on the SFX power supply, you do get one. Let me just show you. You do get one. So this is what the power supply looks like. You have these small, they call them Generation 5 connectors. And it does come with one of these high power cables. We're going to need 2, right? It's going to power 2 GPUs at least or more. And so you need to buy one more of these cords. As you can buy them directly from Corsair, and they cost $30. All right, that's the only part that's really not on the parts list that I'll share with you guys on Amazon, from Amazon. All right, so I ordered these directly. They actually didn't have the black. I had to go with this. If you saw the previous video, it's like white and black. That's in the Lenny machine. I ordered a bunch of these to, one for each machine. I ordered 3. They power one of the, because we only have one cord, they power the A100s in the other machines. All right, let me pause this and I'll bring you guys around and show you the servers, show you what they look like a little bit, some of the things I did on the build to make everything fit, and we'll leave it at that. All right, one sec. Okay guys, here's one of the servers. It's actually the first one that I built. It was originally housing 4 4090s, and I switched it to the A100s. You can see it. This is the UPS that I just told you about that goes up to 1,000 watts, and this is the one that failed. This has a max of 900 watts, and you can see sometimes it'll jump above 900. Yep, and that's not like, I still need to switch these. If the power goes out when that thing's above 900 watts, it will just totally shut off, and this machine will shut off. So I still need to swap these two. I need this powering the main power supply, and this one to power that little SFX. But here's the machine for A100s. Pretty much just like the one that I had built downstairs, but you can see that they have the different, those gray fans that are half the price. But same radiators and everything. I can show you on the side here. Here's the push through the 480 millimeter. All right, 2 pumps, and I'll show you we have the push pull on the front. All right, 4 fans on the back side of this front radiator, and I can pull this off. There's the front. And then the push-pull on the top, 3 fans pushing through the top radiator. You can see it, the thickness was an issue, right? So that's why I settled on this thinner 360, and I didn't go longer because I need this space over here to kind of connect to the reservoir. But I probably could have made it work, but plenty of radiators. And then there's the fans on the top. I don't have all the guards on. It's not necessary. Really, these are blowing up. I don't want to restrict any of the airflow on this thing. Okay, so I did put a box fan on the back here, right? So there is a decent amount of heat that collects on. So without a lot of like air circulation, there is a decent amount of heat that will collect around. This is the old power supply I talked about. I don't use these anymore. I use the Thermaltake that I have on the list, but there's a lot of heat right here, and there's fans pushing through this direction, but it's not enough really to push this heat out of here, and it kind of collects in this area. So I like to have a fan at least circulate, getting this heat out of here. Otherwise it'll kind of accumulate and everything runs warmer without this box fan here. It would be fine if it was in a room that had better air circulation, but this is a big room with like not a lot. This is a big like kids game room that doesn't have a lot of air circulation in it. So that's this one. This is the first build. I'll show you the second one. Invaded another bedroom here. Second one, still using the same parts exactly. Same power supplies, you can see. Same power supply, the EVGA and the SFX. Everything's identical here. I have a box fan just blowing up on the side here. Again, to eject that heat that accumulates. And again, I had the same, but I did make the switch here. This one's running the main power supply. This one's running the small one, but now I just want to use these all the time. And that's what I did on the third one. Here's a little remote control I talked about in the parts list. You can turn this, you can do different colors, all that. This isn't about looks really, but it is nice to have this light so you can look in there and make sure everything's fine, no leaks, that kind of stuff. But yeah, that's build 2. I won't take it apart, but you can see the same stuff here. 3 on the top, 19 fans total. All right, I'll go down and show you the last one, which was in the previous video. I'm gonna pause this and walk down. Okay guys, once again, the third build. Let me turn some lights on here. This is actually, I'm turning this room into a complete data center.
which is kind of interesting. I'm going to put all of the servers in here, and any new servers that I build will go in here as well. I'm going to put a window AC unit over there. The reason is this room was actually flooded recently, and so it's kind of wrecked anyway. We got it all cleaned up, but I didn't repair it because I'm like, oh, I might turn this into a data center. I had some electricians come out and put a whole bunch more electrical lines in, and so that each server can be on its own electrical line. But again, here's the third one that you saw in the previous video. Again, I made the adjustment to use these same UPSs for both. The 4 cards, the card we just installed, and we have, in this one though, those louder fans, and you can hear how much louder they are, I hope, on the video. They're quite a bit louder, and they're not revved up right now, but when they do, it can get kind of annoying. So if you care about sound, probably go with those other cheaper fans. But if you care about performance, you don't care at all about sound, and you don't care so much about paying more for the fans, these guys will get the job done. They just pull a lot. They push a lot harder. You can just feel the air back here. And again, like I said, a lot of heat accumulates right here, so it's nice that it pushes out. And and I try to get circulation to get this air out of here, but it's not great on this one right now. So that's it. I hope you guys enjoy the video, and I'll see you next time.